8.3 trig function, values, and angle measures. All right, so these first problems, they give us a triangle and they give us an angle A, and they want us to find sine of A, cosine of A, and tangent of A for the given triangle. So 12 looks like this. Angle A is over here, and then they give us the side lengths of that triangle. And they want us to find sine of A, cosine of A, and tangent of A. So sine of A would be what in this case? It's the so part of SOHCAHTOA.
Oh, so opposite hypotenuse, opposite over hypotenuse.
So, yep, so 45 over 53. Cosine is what?
Adjacent over hypotenuse.
Adjacent, so that's the one touching it. So 28 over the hypotenuse is 53. And tangent?
Opposite over hypotenuse.
Nope.
I mean,
Opposite over adjacent.
Yep. Opposite over adjacent, so 45 over 28. Let's see, 14. They give us, whoa. This triangle, this supposedly is supposed to be a right angle here. Doesn't exactly look like it in my drawing, but we'll just pretend. Then they say that this is angle A here. This is side Z, side K, and side Y. So this one's kind of weird because of the way it's oriented. It might be easier if you look at it like that, just to be able to see it. But what would the sine of A be?
Opposite of hypotenuse.
So what is that?
That would be, K over Z.
K over Z. The hypotenuse has to be opposite of the right angle, so. Cosine of A. Somebody besides Will.
Y over Z.
Yep, so adjacent right here over Z. Tangent of A. Someone else.
K over Y.
Yep, K over Y. All right, and these next ones, they're going to give us side A and side B, or like side B, side C, something like that, some combo of sides. Okay, C is always going to be your hypotenuse side, and then they want us to find the third side. Okay, how might we find a third side of a right triangle?
It would be 90, right?
Third side.
Oh, third side.
Like
we
if...
do A squared plus B squared equals C squared.
Yes, Pythagorean theorem. So we're going to use the Pythagorean theorem to find the third side. Then we're going to find the 6 trig functions of angle B. So these ones kind of have a lot to them. So 16. Side A is 3. Side B is 4. And side C is always going to be your hypotenuse for these problems. So I typically like to draw my triangles like this. I'd, try to make it more of a right triangle. Now, I know that I'm solving for angle B. That's what the instructions say to do. So I'm going to put angle B right here. Just because visually, I don't know, for me it's easier to see it if it's right there. So side B has to be opposite of angle B. So this right here has to be side B, which is 4. Then this bottom side would have to be A, which is 3. So now I need to find the other side. So that's going to be C squared is equal to 3 squared plus 4 squared. What? What'd you say?
5.
Yeah. Do you know why?
Because it's the root of 25, right?
Well, yeah.
Yeah.
Yeah. It's a
Oh, I
Pythagorean
was
triple.
saying
But
that.
yes. C is 5. So if you take the square root of both sides, then we would get 5. So, but yes, it is a Pythagorean triple. All right, so now we need to find sine of B, cosine of B, tangent of B, and then we'll find the other ones after we do that. But what is the sine of B?
4 over 5.
4 over 5. Somebody else give me cosine. 3 over 5. Somebody else give me tangent. 4 over 3. Somebody else give me cosecant. 5 over 4. Secant.
5 over 3.
Tangent. Or cotangent. Let's see. Let's do 20. Twenty tells us that side B is 8 and side C is 11.
Is it a right triangle?
Yeah, all these are going to be a right triangle. I guess it doesn't technically specify that in the instructions, but they tell you to use the Pythagorean theorem, which would imply that it has to be a right triangle. So again, angle B has to be here, or well, it doesn't have to be, but it can't be the right angle. But I like to do it there because it's easier to deal with. So side B is opposite of it, so it's over here.
This one.
Side C is 11, and I need to find the other side. So in this case, normally I have a squared plus b squared equals c squared. But I have side C and side B this time, so I'm going to move this over. So a squared is equal to c squared minus b squared. So a is going to be equal to the square root of 11 squared minus 8 squared.
58.
Maybe.
Because 122 minus 64.
I think it's 121 minus 64.
Oh. So be 59.
57.
57. Darn it.
So square root of 57, and we'll just leave it like that. So square root of 57 is that side there, which means I'm going to have to rationalize. Okay, so when you give me these answers, give me the initial answer and then rationalize it if applicable. So what's the sine of B?
8 over the root of 57.
Sine of B. Opposite over hypotenuse.
Oh, 8 over 11.
8 over 11. Cosine of B.
The root of 57 over 11.
Root of 57 over 11. Tangent of B.
8 over the square root of 57.
And then how do I rationalize that? I can't have a radical on the bottom.
You gotta multiply both sides.
You mean both sides are top and bottom?
I mean, yeah, top and bottom.
By what?
Like the square root of 57.
Yep, so it's going to be 8 root 57 over 57. Leave a lot of room. Cosecant of B. 11 over 8. Secant of B.
11 over root 57 should be 11 root 57 over 57.
Yep, 11 root 57 over 57. And cotangent of B.
Root of 57 over 50. Root of 57 over 8.
Yep, root of 57 over 8. And when you've rationalized, it's always better, like you did, to use the original one, because then you don't have to, like, unrationalize it. Just makes for a lot more work. We feel okay with those ones, setting them up? Okay. All right, now you are going to need your lovely unit circle. I need to find one. So these problems say to give the exact value of each expression. So that means give the xy value for that particular function. So 32 is the cotangent of 30 degrees. So we're going to look at our unit circle. Okay, so 30 degrees is here, and this value out here is my, oh, it's drawing circles through my paper. That's nice. So this value out here, okay, is the tangent, but cotangent is what relationship? Like when we had tangent here, how do we get cotangent?
We flip the
Oh,
So we're going to need to flip this, okay? So it's going to be 3 over root 3. But what's the problem?
The root of 3 should not be at the bottom.
So what do I do about it?
You put it on the dot, and then it would just be root of 3.
Yep, so I'd have 3 root 3 over 3, which then reduces to root 3. Let's see. 34. What is the cosine of 30 degrees? I don't have to do any manipulating for this one. So is cosine x or y? X. So cosine is x. So what is the cosine of 30 degrees? Out of this coordinate pair.
Oh, root of 3 over 2.
Yep, root 3 over 2.
Is that it?
Yep. 36. Cosecant of 30 degrees. So what is cosecant related to? Which other trig function?
Sin.
Sine. And what's the relationship there?
Split.
Flip it. So we look at the sine of 30 degrees is what?
Uh,
1/2.
1/2. So we're going to flip it,
dos.
and it'll be 2. Let's see. 38. Secant of 45 degrees. I feel like we had this one on the quiz. Or something similar to it. So secant goes with what function?
Y.
Cosine. And the relationship between secant and cosine is?
Flipping.
Or flipped. So what is the cosine of 45 degrees?
2 over the root
2 over the root of 3. Wait.
Cosine would be
Oh,
root
yeah,
2
root
over
2.
2. So then secant would be what you said, 2 over root 2. So 2 over root 2, but we've got to do what? Rationalize it, which would be 2 root 2 over 2, which simplifies to root 2. Cotangent of 45 degrees. So what's the tangent of 45?
1.
So what's the cotangent?
1.
1. Uh, 46. Or well, yeah, 46. Cosecant of 60 degrees. So secant goes with which function?
Same.
Sine. So and so is sine x or y?
X. Which is Y.
Y. Okay. So the sine of 60 degrees would be root 3 over 2.
Uh-huh.
So what is the cosecant of 60?
2 over root 3. And that would be 2 root 3 over 2, which would just be root of
Nope.
3.
2 root 3 over 3.
2 root 3. Oh, yeah, over 3.
So those ones are the ones that end up looking kind of weird, but. All right. Any questions on those ones? Then find the exact values of. Don't wanna do that.
Nah.
Let's do one of them just so you've seen it. But 72, 315 degrees. And they want us to find all 6 trig functions of 315 degrees. So they want us to find the sine of 315 degrees. They want the cosine of 315 degrees, the tangent of 315 degrees, and then so on and so forth. Oh, not that. Let me move this over. All right, so using your unit circle, 315 degrees is on the unit circle, so what is the sine of 315 degrees?
Negative root 3 over 2.
315 degrees.
Root of 2.
Oh.
Negative root of 2.
My numbers are
Negative.
weird on my unit circle because this is my quiz.
negative root 2 over 2. Okay, so 315 is here. So negative root 2 over 2 is sine. What's cosine? Root. Yeah, root 2 over 2. What's the tangent of 315 degrees?
-1.
What is the cosecant of 315 degrees?
Root of 2. Negative root of 2.
Yeah, so we would have negative 2 over root 2, which rationalized is going to give us negative root 2.
It's the same from the next. No, just root of 2 on the next one.
Yeah, so the next one's going to look the same way. It would be 2 over root 2, which would simplify to root 2. And cotangent,
1.
negative,
It's negative.
because it's just this flipped. This is negative 1 over 1, so it would still be negative 1 over 1. Any questions on those? Now, part of the reason I said we're only going to do one of them and I'm only going to give you one in the homework is because all the rest of the angles are larger than 360, which means you would have to find the coterminal angle and do all of that, and we're not doing
Oh,
that.
because if it's over 360, you just, once you did 360, you just add as many after.
Yeah, you just have to keep going past that to get it, so. Still values are on the unit circle, but like they have one of them that's negative 2,205 degrees.
Yeah, I'm good.
And I don't really think y'all want to find the trig functions of that angle. So, I'm going to give you the one that's under 360. But any questions about any of this? All right.
Don't get a 2,000.
I'm not going to do that to you.
How long would that take? That would take long.
Well,
No, you just have to find the.
I would multiply 360 by like
Oh.
5 or 6
I need to
and
stop.
subtract that off and then see how much more I needed to subtract off after that. All right, 11, 15, 19, 31 through 45 odd. Those are just the ones off the unit circle of just reading off the numbers and putting them down, or might like a slight manipulation like we just did. And then 71.